So this is pumping lemma for CFG. Using this pumping lemma, we can check whether the given language is context-free grammar or not. So we can satisfy the conditions. Then after that we can apply this pumping lemma. Again, it still belongs to L. We can say it is context-free grammar. It does not belongs to L. We can say it is not in context-free grammar. So this is one example. Let L is equal to A power n and B power n. So equal number of A's as well as followed by equal number of B's. We are going to check whether it is context-free grammar or not. Okay. For using this language, we can derive for n is equal to 1, n is equal to 2, n is equal to 3 up to at least a minimum 5 to 10 iteration. We can identify whether it is belongs to L or not. So I am just assuming n is equal to 3, then L is equal to A power 3 and B power 3. Here we have to satisfy the conditions modulus of V, W, X and Vx greater than or equal to 1. So we can take, we can assume the U, V, W, X, Y, but we have to satisfy the conditions. Modulus of Vx, for example, here V and X greater than or equal to 1. And it does not epsilon. V and X always does not epsilon, but U, Y, W may be epsilon, no problem. As well as the length of the substring V, W, X less than or equal to n. Here we can take n is equal to 3 means definitely equal, otherwise less than or equal to n. Yeah. So after that we can use the pumping lemma. For example, n is equal to 1, we are getting the language A, B, n is equal to 2, n is equal to 3 like this. Then we are going to check whether it is accepted or not. For assuming n is equal to 3, we are getting the string. Here we can set we can break the value u, v, w, x, y. Then here we are going to apply the pumping lemma. Initially I is equal to 1, always greater than or 1. And initially I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4. I is equal to 1 still belongs to the language because triple A and triple B. Then I is equal to 2 also. Again 4 number of A, 4 number of B. Then A is equal to 3, 5 number of A's, 5 number of B, like that. Yeah. So we can say A power n, B power n is belongs to L. How many iterations goes on automatically, still it belongs to L. So it will satisfy the condition A power n, B power n. Again we are going to check one more language, A power n, B power n, C power n greater than or equal to 1. So we are getting n is equal to 1, 2, 3. I am taking this n is equal to 2, A power 2, B power 2, C power 2. So we can divide U, V, W, X, Y. You are going to pump V and X. We can set I is equal to 1. Still we are in the same language. I is equal to 2. You are going to pump this A alone. Then B here. So what is the answer? A, double A and B, double B and double C. So what is the condition for n is equal to 2 means? So we need double A, double B, double C. Yes, here one more A, one more B is here. So equal number of A, B, C not here in this language, so that the given grammar is not in context-free grammar. Thank you.